All right, happy virtual day, Trig students. So we are going to look at, you should have the packet, you should have the notes that we gave yesterday. 2.1 is going to be today and it's going to be tomorrow. So need you to go through these few videos and take these notes, and then you'll see an assignment, and I'll probably have some office hours as well that you can come and ask some questions. So grab some coffee, and here we go. 2.1. So we finished chapter 1. Chapter 1 was all on SOHCAHTOA and right triangle trigonometry. Now we're going into trig identities. This is more of an algebraic section. This is more of algebra review, problem solving, and looking at identities. So we'll jump right into it. So we're just kind of making statements about these little equations. So the sine of an angle, the sine of u is also equal to, I couldn't say it's equal to cosecant, that's its reciprocal, but I could say it's equal to 1 over cosecant u. So, and that is true. That's an identity because the sine is equal to 1 over that. The cosine of u would be the same thing as 1 over the secant of u. The tangent of an angle, the tangent of u, would be identical to 1 over its reciprocal, cotangent of u. If we go over here and we say, well, let's talk about the cosecant. The cosecant would be the same thing as 1 over the sine. The secant would be the same thing as 1 over the cosine. The cotangent would be the same thing as 1 over the tangent. So these are identities that we already know from chapter 1. The sine and the cosine are reciprocals of one another. Therefore, it would just make logical algebraic sense that these things also have to. All right. So now we kind of go down to what are these quotient identities? Quotient identities, okay? Well, this all comes back to the unit circle. So if we think about our unit circle, there it is. We defined sine and cosine and tangent as the x value or the y value or a ratio of the x and the y of some sort, right? So we think about tangent, well, we defined, well, let's just go over all of these, right? The sine of an angle was always the y value. The cosine of an angle on the unit circle was the x value. The tangent of an angle was always y divided by x. Right? So if we just look at these terms right here, we can also conclude, right, that if sine is y and cosine is x and tangent is y over x, then it would just make sense that the tangent is equal to the sine divided by the cosine, right? So that's all the quotient property is saying. We're looking at the unit circle and just making more conclusions and taking next steps to what these identities are. So the tangent of an angle, we could say, is also the same thing as the tangent of u. Again, we're just using u here. It could be theta, it could be x, doesn't matter what that variable is, divided by the cosine. So this is a big one right here. So if tangent is y over x, then it would make sense to also say that the tangent of an angle is equivalent to the sine of the angle divided by the cosine of the angle, and that's a quotient property. Cotangent of u is x over y, so it would make sense to say this is equivalent to cosine over sine. Okay, so now we have these reciprocal identities, which we already knew. But we're just kind of laying them out and starting from scratch and kind of saying, we know the unit circle, we know SOHCAHTOA. What other conclusions can we make based off of our kind of setup here? So let's keep looking at the unit circle. If we look at the unit circle, we also know the Pythagorean theorem. Right? That's something that we always know. And when we drew an angle on the unit circle, we could, draw an angle like we see here, and then we could always imagine, right, a right triangle there and drop a little spot here and go like that and that. And if we did that, we could label these sides like we've done before. We would say, well, let's think of this as the x side, this is the y side, and what's the hypotenuse of a unit circle? Well, it's always 1, right? So if we were to look at this and think about all the tools that we have in Trig, again, we've been using the same ones over and over. We have SOHCAHTOA, we have right triangle trig, we have Pythagorean theorem. So if you were to just look at this and say, well, you know what? We have a right triangle. The Pythagorean theorem must hold here, right? So it should be obvious here that if I said x squared plus y squared is equal to 1, that makes total sense. That's the Pythagorean theorem for really any angle on the unit circle or in standard position. This should make sense to you, okay? Now, if x squared plus y squared is equal to 1, and we know that, wait a second, the x value on the unit circle, the x value is just equal to cosine. And wait a minute, the y value is just equal to sine. Then if we just make one little substitution here, we could just conclude that, well, the sine of theta, and so I wrote that backwards. Let's start with the cosine of theta squared plus the sine of theta squared is equal to 1. And you can see that I'm just making a substitution here. For the x, I'm just putting in cosine. And for the y, I'm just putting in sine. That's it. So then that statement, cosine theta squared plus sine theta squared is equal to 1. That should make perfect sense. And that's actually one of these identities, these Pythagorean identities. Now, one thing to note, that when we take cosine of an angle squared like we see here, a shortcut way to write this is to just say, put the squared value right here, cosine, and we put the squared value right here instead. That means the exact same thing. So cosine squared theta is how we would say that, plus sine squared theta is how we would say that is equal to 1. So this right here is basically just the Pythagorean theorem. That's all it is. Okay, but that's looking at the unit circle setup that we already had. So when we look over in this spot, that's where all this is coming from. So now let's go ahead and write our Pythagorean identities, but we just kind of showed why that works on the left-hand side. So it says sine squared u, again, we're not using theta here, we're using u, sine squared of an angle plus the cosine squared of an angle is always equal to 1. So this is the Pythagorean theorem, but we call it this Pythagorean identity because we're applying it to the trig that we already know. Now below it, we have 1 plus tangent squared equals something, and 1 plus cotangent squared equals something. All right, so how do we get these? So I'm going to do a little explanation here. Okay, if I were to say cosine squared plus, or sine squared plus cosine squared theta equals 1. If I wanted to take this identity and just change it up a little bit, make it look slightly different. Let's just say, for example, I divided every single term here, left and right hand side, by the same thing. Let's just say we did it by sine squared of u. Sine squared of u, sine squared of u. I just divide everything by the same side. We know in algebra, if I take an equation and I just divide everything by the same thing, it's still an equation. So that's what we're doing here. I'm just shaking this up a little bit. So if I were to take, each and every single thing here, sine squared of u plus sine squared of u, well, if I did that, that would equal 1. If I look at this, if I have cosine squared divided by sine squared, and I think, well, what is cosine divided by a sine? Look over here. cosine divided by a sine is equal to cotangent. So this actually becomes cotangent squared u equals, and then if I look over here, what is 1 over sine squared of an angle? Well, 1 over sine squared of an angle is cosecant, right? So this is equal to cosecant squared of an angle. So this right here is basically the same Pythagorean theorem, but I just changed it slightly. Made it look different because I just divided everything by sine squared. So anyways, this is the identity that you can see the last one right here. So we're going to write this in. It says 1 plus cotangent squared u. What is that equal to? Well, it's equal to cosecant squared u. There it is. Okay. Now, if I take the same thing, and you might know what I'm going to do here, but if I go and let's just shake this up again. Let's just say we take the original identity and let's just go ahead and divide everything by cosine squared u. Cosine squared u. Okay. Well, then if we rewrite that, we would get sine over cosine. Sine squared over cosine squared is tangent, right? This becomes tangent squared u from over here. Cosine over cosine is 1. And then over here, 1 over cosine squared, well, that's equal to secant squared. Okay, so then our last one up here to fill in, 1 plus the tangent squared of an angle, that's equal to secant squared. Okay, so all we've really done here is take what we know from chapter 1, sine, cosine, tangent. We know SOHCAHTOA, we know the Pythagorean theorem. Those are like the big things we learned in trig and in geometry. And now we're just taking that and expanding our knowledge here and making these identities. We're kind of just looking at the algebra and saying, well, if we have the unit circle here, and if we define the unit circle as sine is y, cosine is x, so on and so forth, then what other conclusions, what other statements can we say about our little setup and our little system here? Well, this is a good start here, right? We're just kind of doing the algebra and saying, well, if x squared plus y squared is 1, Pythagorean theorem is true, well then this has to be true as well. And so this is a good first sheet of trig identities that you need to know. And all we're going to do in this section is just use these identities and do some algebra review and solving some problems.